Friends and folks, in dividing polynomials, you learn about the long division and synthetic division. Today, I will present to you a related topic that is remainder theorem. What is remainder theorem? In mathematics, it is simply the method to easily get the value of the remainder under the operation of division of polynomials. So again, what is remainder theorem? In mathematics, it is a method to what? To easily get the value of remainder. Okay. Actually, we can get the remainder out from using long division and synthetic division. But in remainder theorem, we can also get the value of our remainder easily. So, in what way? So again, let me recall to you our concept in dividing polynomials in order to us to have the remainder or the value of the remainder. Okay? If we can recall with me, we have, for example, a dividend p of x divided by a certain divisor, say d of x. Again, if you can recall, we have the quotient q of x. Then after that, we have the remainder. Then the remainder is divided by or over with a certain divisor. So in remainder theorem, we can easily get the value of remainder here. So, or again, if you can recall, this is actually what? This is actually the division algorithm for polynomials. We can also present as p of x is equal to our q of x, which is our quotient, times our divisor d of x plus our remainder. Again, this is called as what? The division algorithm of polynomials. So in this case, you can get the remainder or the value of remainder either in this form or in this form. So what is the beauty of remainder theorem, or how can we use remainder theorem? So first, we will define the theorem. Okay, remainder theorem is what? In a statement, say if the polynomial or a dividend, say p of x, is divided by a certain divisor d of x, okay, of the form say our divisor is of the form x minus r. So again, if the polynomial p of x or dividend is divided by divisor of the form x minus r, we have a relationship that the remainder is the value of our remainder is any real number or constant. and is equal to the form P of R. So again, let me read to you or present to you the definition of our remainder theorem. So the remainder theorem states like this. If the polynomial P of x is divided by a certain divisor of the form x minus r, the remainder is any real number or constant and is equal to P of r. In symbol, we will interpret this one. In symbol, P of x is divided by x minus r. So P of x divided by x minus r, you can get actually your remainder by how? By having this P of r. Okay, so again, dividend divided by divisor x minus r, you can get the value of your remainder by evaluating P of r. Okay, this is simply the remainder theorem. So in remainder theorem, we will get or evaluate the value of P of r. So to make things clear, let me give to you an example. Okay, example number 1. Find the remainder when P of x, or our dividend, 2x cubed minus x squared minus x plus 12 is divided by x minus 2. So we are required to get our remainder or the value of remainder. Actually, if you can again recall, we can get the remainder by long division method and synthetic division. But in remainder theorem, we can easily get the value of remainder. So, solution. So, in figure or in symbol, so P of x divided by x minus r is, we can get the value of our remainder by evaluating P of r. Where can we get our r? The value of r is from our divisor, x minus r. Okay, are you ready? So, in our given, we have P of x equals, again, 2x cubed minus x squared minus x plus 12. In order to get our remainder, we will substitute x with our value r. So we will evaluate P of r. Okay? What is our r? Our r again is from our divisor. So here we have our divisor. Same with synthetic division, we get the value of r. So in our divisor, the given is x minus 2. So x minus 2, then our divisor is of the form x minus r. So in this case, clearly, what is the value of our r? Our r is clearly x minus 2, then x minus r. Our r is r equals 2. Okay? Or you can equate this x minus 2 equals to 0. So equate x minus 2 equals to 0. Then solve for x. So x minus 2 equals to 0, you can actually transpose negative 2 to the right side or add both sides by positive 2. So solve for x, x is equal to 2. So again, by equating to 0, or in this case, our r is equal to 2, we will substitute our r here. Okay, so our p of r is p of 2. Okay, are you ready? So now we will solve our remainder. So remainder is equal to p of r. Our p of r is p of 2 of what? From p of x equals 2x cubed minus x squared minus x plus 12. Okay, we will just evaluate the expression. So we have here 2. Instead of writing x, we will use 2 here. So 2 times our base is 2 raised to the power of 3. Okay, minus 2 squared, then minus 2, then plus 12. Okay, so from here we will simplify. 2 times what, by the way, what is 2 cube? 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So we have 2 times 8. Then what is 2 squared? That is actually 4. So we have here negative 4, then negative or minus 2 plus 12. Then we will simplify. 16 minus 4 minus 2 plus 12. So 16 minus 4 minus 2 plus 12 is 22. So by remainder theorem, by simply substituting or evaluating p of r, since our r is p of 2, our remainder is 22. Okay? So in this case, we able to get the value of our remainder by using the principle of remainder method. But we can also get the remainder value by using long division and synthetic division. We will check 22 by using synthetic division. Check by synthetic division. Okay, can you still recall the synthetic division? Okay, I hope you follow. So in synthetic division, we will use our dividend. Our dividend is in standard form, so no problem. So we will just check our value 22. So in synthetic division, we will write the numerical coefficients 2, negative 1, negative 1, and 12. Okay, then we will write the inverted basta presentation. What is our r? Our r is 2. Okay, so we will write r here. Then we will draw this line. This is the second row and the third row. So our procedure in synthetic division is we drop 2. After dropping, we multiply 2 by our value of r. 2 times 2 is 4. Okay, so we able to multiply that. 2 times 2 is 4. After multiplication, in the column we add. Okay, negative 1 plus 4 is actually 3. Okay, 3, then again 3 times 2 is 6. This third column, negative 1 plus 6 is 5. Then for 5 times 2 is 10. For our last column, we will add 12 plus 10 is 22. Okay? So even in synthetic division is actually our remainder. Even our synthetic division, it shows that we have the same value of our remainder. So 22 as the value of remainder, using remainder theorem, and the same value 22 as the value of our remainder in synthetic division. So finally, therefore the remainder when 2x cubed minus x squared minus x plus 12 divided by x minus 2, our remainder is 22. Let me give to you another example. Say example number 2. What is the remainder when p of x, or dividend 3x to the fourth plus 2x cubed minus 4x minus 16 is divided by x plus 2? We will solve this through a remainder theorem. Again, we can actually get also the remainder value by long division and synthetic division. So through remainder theorem, here first let me write solution. Okay, so a remainder theorem, we have p of x divided by x minus r. We can get the value of our r by what? By evaluating p of r, this is small r. This r is the remainder equals p of r. Where can we get our small r? The value of r is from x minus r, our divisor. Okay? So our divisor is x plus 2. So first, we will clear our divisor. Okay? Let me write in this space. Our divisor is of the form x minus r. But since our divisor, the given divisor is x plus 2, we will rewrite x plus 2 of the form x minus r. So we can actually have this as x minus of negative 2. Okay? X minus of negative 2 is just x plus 2. So clearly, our r is what? X minus r. Here, x minus of negative 2. So r is equal to negative 2. Okay? Do you follow? Or you can equate this divisor, x plus 2. Equate x plus 2 equals to 0. Then solve for x. You can actually transpose again 2 to the right or add both sides by negative 2. X is equal to negative 2. So our r is actually negative 2. So go back to our remainder theorem. R equals p of small r. So we can have this as p of r equals p of our r again is negative 2. Okay, then we will substitute negative 2 from 3x to the fourth plus 2x cubed and so on. So our remainder is equal to p of negative 2. Then we will evaluate this. So p of negative 2 equals, okay, refer to our dividend. 3, instead of writing x, write 3, substitute x, so we will use negative 2. 3 times negative 2 raised to the fourth power plus 2. Instead of writing x, we will use or substitute negative 2. Okay, negative 2 cubed minus 4, substitute negative 2. So that is negative 4 times negative 2, then negative 16. Then we will evaluate. Okay, so here we have 3 times, okay, what is negative 2 times negative 2 times negative 2 times negative 2? Since it is raised to the fourth power. So this is 3 times what? Negative 2 times negative 2 is positive 4. Times negative 2 is negative 8. Times negative 2 is positive 16. Okay? Here, we have plus 2 times, here we have negative 2 times negative 2, positive 4. Times negative 2 is negative 8. So here we have 2 times negative 8. Then negative 4 times negative 2, positive 8. Okay? Then negative 16. Again, we will simplify. What is 3 times 16? That is actually exactly 48. 2 times negative 8 is negative 16. Then plus 8. Then negative 16. Okay? Are you ready to simplify this? Same sign, add and keep. So 48 plus 8 is 56. Then negative 16 minus 16 is negative 32. Now, we have 56 minus 32 is 24. So our remainder is 24. Okay? We're able to get 24 as the value of our remainder through remainder theorem. Let me show to you or verify our answer through, again, synthetic division. Okay? So we will check our answer through synthetic division. Are you ready? So in synthetic division, first, we will see to it that our dividend and divisor are in standard form. Then if we need, kindly check first, 3x cubed plus 3x to the 4th power plus 2x cubed minus 4x, or we need to insert 0 here. Okay? So since we need to insert 0, so we will rewrite in synthetic division, check by synthetic division. Okay, our p of x now becomes 3x to the 4th plus 2x cubed. Here, instead of writing negative 4x, we will write or insert 0 plus 0x squared to accommodate 4, 3, 2. Then we now write negative 4x minus 16. So in synthetic division, we have to complete 4, 3, 2, 1, then 16, x to the power understood 0. So this is ready. Okay? So we will write the numerical coefficients. We have here, help me, 3, then 2, 0, negative 4, and negative 16. So we will write inverted basta presentation. What is our R? Our R is the same with our remainder theorem, value negative 2. Okay. We will try to check if 24 is the same value using synthetic division. Okay. Mind you, synthetic division has advantage over long division. If large exponents are given, it is more convenient to use this remainder theorem. Say x to the 5th, or to the 10th. So it is easy to use a remainder theorem to get the value of remainder. Anyway, bring down 3. 3 times negative 2 is negative 6. Then we will add, okay, 2 plus negative 6 is what? Negative 4. Again, negative 4 times negative 2 is positive 8. In this third column, we will add 0 plus 8 is 8. Then 8 again times negative 2 is negative 16. In column, we will add negative 4 plus negative 16 is negative 20. Then negative 20 times negative 2 is what? Positive 40. Wow! Negative 16 plus 40 is 24. It shows we able to arrive the same value of our remainder from remainder theorem here. So this is our remainder. Okay, so by synthetic division, we have the same value of our remainder. So we really check that remainder theorem works for us. So let me give to you my last example. Example number 3. This is our last example. Okay, under remainder theorem, find the remainder when 2x cubed plus 3x squared minus 2x minus 3 is divided by x minus 1. Okay, we are tasked to get the remainder. Okay, under remainder theorem, we will solve the value of the remainder. So, solution. Okay, so p of x, the dividend divided by x minus r, is the value of r really, or the remainder, is equal to p of small r. Okay, so we will evaluate what is p of r. R from our divisor. So again, in this side, let me write our divisor. Divisor is of the form x minus r. But since our divisor is just x minus 1, so clearly x minus r, x minus 1, so clearly our r is equal to 1. Or again, equate our divisor to get the value of r. Equate x minus 1 equals to 0. Then solve for x equal to x minus 1 equals to 0. So x equals to, transpose to the right, or add both sides by positive 1. X is actually 1. So r is clear, equals to 1. Okay, so go back to our definition. So r equals p of small r. This is just equal to p of what? P of 1. Okay, so our remainder, the value of remainder is p of 1. We will evaluate from our dividend. So p of 1 equals 2. Substitute x by 1. So 2 times 1 raised to the power of 3, or 1 cube. Then, are you with me? 3 times 1 squared. Okay. Then, minus 2 times 1 minus 3. We will evaluate. Help me out. 2 times, 1 cube. 1 times 1 is 1, times 1 is 1. So we have 2 times 1. Okay? Next, plus 3 times, what is 1 squared? 1 times 1. 1 times 1 is 1, times 3 is 3. Or simply 3 times 1. Negative 2 times 1 is negative 2. Then, minus 3. Simplify further. 2 times 1 is 2, plus 3 times 1 is 3. Minus 2 minus 3. Then, what is our final value? 2 plus 3 minus 2. Oh, minus 3. The answer is 0. So, our remainder is 0. In this case, if the remainder is 0, it means to say that our divisor x minus 1 is a linear factor. Linear factor of our dividend 2x cubed plus 3x squared minus 2x minus 3. We will discuss more about factor or factors by a separate video about factor theorem. Okay? So our remainder now is 0. We will check this one by, to make it easier, by synthetic division. Synthetic division. Okay? Kindly look for our dividend and divisor. Is it in standard form? 3, 2, so no problem. So we can write their numerical coefficients. 2, then 3, negative 2, and negative 3. Then we'll write our inverted pasta presentation. What is our R? Our R is 1. Okay. We'll complete the process. Bring down 2. 2 times 1, 2. Then we will add the second column. 3 plus 2 is 5. Again, we will multiply 5 times 1, 5. The third column, negative 2 plus 5 is 3. 3 times 1. Oh, 3. So, negative 3 plus 3 is 0. So, again and again and again, we able to really verify that by synthetic division, we have the same, or we arrive at the same value of our remainder. This is our remainder. Okay. I hope you are convinced, or I hope you learn something about remainder theorem as a shortcut method to easily get the value of our remainder. So again, if our remainder is 0, it means to say that x minus 1 is a linear factor of our dividend. So out for that. Thank you, and may God bless us all. Okay, I hope you subscribe. Thank you.